learned how to multiply polynomials. We got good at that, hopefully. We're moving on to division of polynomials. We're going to learn like 3 different ways to divide polynomials. This lesson, we're going to learn what's called the reverse tabular method. We learned the tabular method for multiplying. Now we're going to learn, it's called the reverse tabular method for dividing. Because, you know, the division is opposite of multiplication. So we reverse the multiplication. It's actually dividing. So obviously I want to make sure we're good and we have a review on the tabular method. So recall from lesson number 5, I want you to pause the video quickly and do this, fill that box in there. You have to draw that box and fill that in that you see on your screen. Go ahead and do that now. Alright, and hopefully you've done that now. X squared times 2x is 2x to the third. 5x times 2x is 10x squared. 1 times 2x is 2x. We got 5x squared plus 25x and then plus 5. Alright, so now our diagonals line up. We get 2x to the third. We get 15x squared. We get 27x. And we got 5. So our product is 2x to the third plus 15x squared plus 27x plus 5. Alright, good stuff. How the reverse tabular method works. We're going to talk about how it works, and then you're going to hopefully use this one to kind of go on and actually do it. So this example here isn't really going to be you actually doing the reverse tabular method. You're just seeing how it works. Basically, here is a division problem they're giving you, and they're giving you, this problem is actually giving you the answer. Okay, all I want you to do is see the setup and see why it works. When you were multiplying, you would put the two polynomials, one on the top and one on the side. Well, when you're dividing, what you're actually doing is you're trying to find one of those that is missing. You're trying to find the missing polynomial, because if you were to find that, you multiply it by the other given polynomial, that would get the resulting product. This time you're trying to find the quotient, so you're trying to find what is up here. Okay, see how they're giving, you have to pretend they gave you this. They gave you this, and the 2x plus 5 is the divisor. The divisor is going to go on the one side of the box, and the dividend, okay, the dividend is the top of the fraction bar in this case. That's not going to go up here, because if it does, then that means we'd be multiplying those things. We don't want to multiply them. We want to find out the quotient. The quotient's going to be up top here. This right here is essentially what you get after you if you were to multiply this quotient times this binomial here, that's what you would get. You would get this 2x to the third plus 15x squared plus 27x plus 5. So that's actually what goes outside the box, this dividend. 2x to the third, 15x squared, 27x, and 5. So now again, you know the answer of the tabular method. Okay, you have the answer and you're kind of going backwards. You have to use your box. And in this case, they already also gave you this. All right, they gave you the quotient. So we know it's going to be x squared plus 5x plus 1 up here. That is going to be the answer, but they're asking us to justify why it's the answer. Why is it the answer? Well, you do use the tabular method. X squared times 2x is 2x to the third. This is going to give you 10x squared, 2x, 5x squared, 25x, and then 5. Now look, 2x to the third's right here. See these here? That's 15x squared. This here, 27x, and then there's the 5. All right, so basically the tabular method kind of shows you how this reverse tabular method is going to work. How do you actually do it, though? I'm going to start off with an easy one. All right, x minus 2, your divisor, is going to go right here. Your dividend is the top of the whatever you start with in your division problem. That's your dividend. That's going to go outside the box. I'm going to call that 1x minus 10. And you have to fill in the box, and once you fill in the box, as you fill in the box, you can kind of piece it together and get that quotient, which is going to be up top. How do you do this? It's kind of what I actually like doing these because I like puzzles, all right? And really, these are puzzles, all right? There's clues, and you have to use the clues to fill in the box and then kind of work backwards. So, what do I know? Well, see this arrow here? It's pointing to one box, isn't it? 2x squared is pointing to one and only one box. So guess what? That box better be 2x squared. What else could it be? So, if that's 2x squared, and this is an x right here, what do I need to multiply x by to make this a 2x squared? So you can tell what this is going to be. You could tell this must be 2x because I need 2x squared here. 2x times x is 2x squared. All right, so if I'm going too fast, make sure you pause and rewind and listen to the explanation again. So again, this has to be a 2x squared because of this right here, this arrow, and then 2x times x is 2x squared. So I know that this is 2x. I already got the first part of my quotient. I already got it. I already know this is going to be equal to 2x something, 2x plus or minus something. All right, well, once you know this is 2x, and this is a negative 2, now I know this is negative 4x. Okay, well, see this arrow? This arrow points to this diagonal right here, and the total of this diagonal is 1x. The total of this diagonal is 1x. But I know this is negative 4x. I need it to be a 1x. So what do I have to put in this box so that it'll total up to 1x? Excuse me. It must be 5x. Okay, see that now? Check it and check it. 5x minus 4x, 1x. All right, now this is 5x. This is x. Well, then what must this be? This must be a 5 because 5 times x is 5x, and I know that was 5x. And now 5 times negative 2 is negative 10. And look at that. Well, we knew that had to be negative 10 because that's the only box for the negative 10 out here. So I got my box filled in. The box really means nothing. The box is just the work. It's kind of like this multiplied out or expanded out. But this right here up top, that is your quotient. So that is the answer to your division problem, 2x plus 5. Hope you like that. I love it. Great stuff. Great stuff. Now, no table given. How do you know how big to make the table? Because if you're doing a 3 by 3 and you're multiplying, I know I need 3 rows and 3 columns. Multiplying is easy. Whatever they give you, that's how many columns you need. That's how many rows you need. But you don't know exactly how many terms are going to be in your answer. So there's a way to do it. And this is the process. I'm going to give it to you. For the number of rows, you're going to have to fill this in. It's going to be something you're just going to have to memorize. The number of rows is 1 more than the degree of the divisor. Divisor. Okay, 1 more than the degree of the divisor. So that's easy. So here's my divisor, x squared plus 2. I'm going to put rows here to figure out number of rows. I use x squared. My degree is 2, so I just go one more than that. 2 plus 1 equals 3. That means I have to have 3 rows. Okay? Just take the divisor, take the degree, which is the highest exponent, add 1, and you got your number of rows. Very, very simple. For columns, it's a little trickier. It's not too bad. It's 1 more than the difference between the degree of the dividend and divisor. So for the number of columns, you have to take the dividend into consideration. So for number of columns, for this one, NS, the number of columns, we have to use the degree of the dividend and the degree of the divisor both. So 4 and 2, 4 minus 2, difference, 4 minus 2 is 2, and then add 1 and you get 3. So you're going to need 3 columns as well, but if for a different reason. Again, for rows, you just add 1 to whatever you see on the bottom there, the degree of the divisor. For columns, you have to subtract and add 1. Subtract the degrees and add 1. So I know I need a 3 by 3. All right, so let's do that now. Go ahead and set up a 3 by 3. This one. Okay. There's my 3 by 3. I know that x squared, I have to have a 0x, and I have to have a 1. Got to have everything. If it's a second degree, every term's got to be represented. There's 0x there. I know that my x to the 4th, that goes there. Along this diagonal is going to be 4x to the 3rd. Along this diagonal is going to be 3x squared. Along this diagonal is going to be 4x, and this diagonal is going to have just the 2. So again, dividend goes along the outside, and now we're going to start our puzzle. Ready to start our puzzle. All right, always start with the first one, or you can start with the last one and work backwards, whatever you prefer. But x to the 4th has to go here. All right, if that's x to the 4th and that's x squared, I need x squared here because x squared times x squared is x to the 4th. Once you know one of the values in the dividend, multiply it down using the tabular method, regular tabular method. So x squared times 0x, 0x to the 3rd. X squared times 1, x squared. All right. Next one, next diagonal, 4x to the 3rd. Okay, well this is 0x to the 3rd. My whole diagonal here, this right here, that needs to be a total of 4x to the 3rd. I have 0x to the 3rd here, so this must be 4x to the 3rd. That must be the whole thing, 4x to the 3rd, so that they add up to 4x to the 3rd. Okay, that's 4x to the 3rd. I have x squared here, so this must be 4x. 4x times 0x, 0x squared, and then 4x times 1 is 4x. Next one. Next diagonal. The big one. That's got to add up to 3x squared. Well, I have 1x squared, I have 0x squared. How am I going to get it to be 3x squared? I need a 2x squared. I need a 2x squared so that it adds up to 3x squared. So this must be a 2 because 2 times x squared is 2x squared. This is 0x, and this is 2, which it had to be a 2 because of that 2 right there. All right, so we got it. This is positive, positive. So my quotient is x squared plus 4x plus 2. All right. This is a biggie. Big guy, big guy, big guy. What I'm going to do is I am going to save example 3 for class tomorrow. It's the first thing we're going to do. All right, so remind me in class. I'm going to put save for class. Save for class. Because this is something I actually do want to make sure I do with you a little bit, even before the warm-up. And we're going to move on to do example 4. We're going to get plenty of practice here in example 4. This time it's a x to the 6. So you need 6x minus 1. X minus 1. All right, and then you're going to have x to the 6th, and then this needs to be, again, 0, 0, 0. They're all 0, 0, 0. You get the idea? Because there's no x to the 5th, no x to the 4th, no x to the 3rd, none of those. And then we have a negative 1 at the end. So we know that's negative 1. All right, x to the 6th, we know that's x to the 6th. X to the 6th, this must be x to the 5th. You might already see it, the pattern. Minus x to the 5th. This needs to be 0. This has got to be x to the 5th. So this has to be x to the 4th. All right, well then this has to be negative x to the 4th. X to the 4th. Negative, oh I'm sorry, x to the 3rd. Negative x to the 3rd. X to the 3rd. X squared. Negative x squared. X squared. X. Negative x. X. 1. Same pattern. Answer, x to the 5th plus x to the 4th plus x to the 3rd plus x squared plus 1. You're going to need to take a look at these in order to do tomorrow's warm-up. All right, example 5. This time we're going to be looking at division in which we get a remainder. So it's not going to work out so nice all the time. And, you know, you can get remainders like simple if I do something like this off on the side. If I do, 21 divided by 4, okay? Well, 4 goes into 20. It doesn't go into 21, it goes into 20 5 times. 4 times 5 is 20, and you get a remainder of 1, right? So sometimes you can have remainders in division. You can have remainders when you're doing the reverse tabular method as well. So I'll show you how that works. So rows and columns. This is a 1 here, right? X to the 1st. So we go 1 more than that. So we're going to have 2 rows. And then we subtract 3 minus 1 is 2, and then add 1. So that's 2, and then add 1, so 3. So 3 columns. All right, so we're going to need 2 rows, 3 columns here. All right. Now, what we're going to do, and from here on out we're going to do this when we're doing reverse tabular. There's our 2 by 3. We're going to put an extra box, and that's going to be our remainder box. In fact, I'm going to change colors here, make it a different. Okay, that's going to be our remainder box. Now, I'm going to put the x minus 7 here, and up top, I'm going to put. Well, I'm sorry, up top we don't put anything. That's our answer is going to be up top. Here, we're putting back in these. So it's x to the 3rd, just like we did before. Negative 4x squared. and then negative 26x, and then 33. Okay, but this time, so we're going to put, we know x to the third goes here. So x to the third times what gives me x? I know this is x squared. And then x squared times negative 7 is negative 7x squared. And then these have to add up to negative 4x squared, so I need a positive 3x squared here. And then 3x squared, what times x gives me 3x squared? Well, that has to be a positive 3x. And then multiply down, 3x times negative 7, negative 21x. And this diagonal has to add up to negative 26x, so this needs to be a negative 5x, and then this needs to be a negative 5. The problem is, negative 5 times negative 7 is 35, not 33. See, we got a 35 because that had to be negative 5, and then times negative 7 is positive 35. It's not giving me the same number that I should have from up here. That's how you can tell there's a remainder. Okay, well, that's why I have that extra imaginary box there. That's going to be the remainder. What do I need? Keep going. What do I need on this diagonal to give me 33? Well, I need 2 less. I have 35. I need 2 less. I need negative 2. That's my remainder. That is my remainder, negative 2. Okay? So now I can write my answer. X squared plus 3x minus 5. And this is how you're going to write the remainder. We're going to be doing more and more of this. You'll get used to it. We're going to go plus, but instead of plus, it's minus. So we're going to go minus 2 over whatever you were dividing by, x minus 7. Okay, it's kind of like with our original example when you had 21 divided by 4, and we got 5, remainder 1. Well, that's really 5 and 1/4. When you get a remainder of 1 and you're dividing by 4, it's really 5, whatever the number is, and 1/4. So that's kind of what you're doing here. 2 is the remainder over whatever you divided by x minus 7. So you'll get, that's kind of weird, I know, on the first time you see it, but you'll get this, practice it in class tomorrow, in the next few days, and even next week we'll practice it even more. So I'll see you then.